All right, so today we are going to be talking about Module 2, Section 15, which is going to be focused on SQLite. So we've done SQL already back in Mod 1, if you remember. I think it's like Section 5, really early on and everything. What was I going to say? SQL, we're going to talk about SQLite. We're going to do SQLalchemy. We're going to see some object-oriented programming like we had before, which I know everyone just loves, object-oriented programming. But we'll see actually it being used in that sense of, yes, with SQL. So I'm going to start sharing my screen. And if I can find the right, are you it? Yep. Okay. Always have trouble finding the right, so you guys should all see now SQLite, some code right here. Look good, do you guys? Okay, cool. So, all right, so first thing, SQLite 3. This is kind of more of a review more than anything. So just remember that it's a package right here, SQLite 3. We can connect to a database. In this case, I'll kind of show you, I believe, let's see here. And this is all on the resources on GitHub that I post up. So just know that's updated. That's where you can find this stuff. So SQLite, you can see right here, there's only these files. If I try to connect to a database called example.db, okay, this will actually create a new database if it does not already exist here. And then I can also do the connection to the cursor. So this should be review, but just kind of remind you guys. And now you can see I created one. And you should now see, oh, we haven't written anything to the database, but there's no .db file. Once I start writing things to it, it'll create a file automatically. For example, if I create a table now called stocks with all that information, you should now see example.db. Okay. Note, however, now this is a file. You could try opening up this file. It won't work. It won't give you any information like in that classic sense. It's basically compressed in certain ways and written in different ways that you could try opening it up, but basically there's a special way for it to access this information. And most databases are like this. They're optimized in some way. And so they're not like a normal text file, like a CSV file. You can open it up and look at all the data. Databases files are structured differently. And if you want to, you could always connect to a remote, server or something that's on the network. In this case, it's just a literal file, but it could be another connection. Now, depending on what kind of server you're connecting to and where that server is located, that will define how you put in your connection for your URL. But just note that you can do that, okay? So again, creating our data table, pretty simple. We're making a stocks table, date, trans, simple, quantity, price, okay? And then with this, we can also execute, right? Our c.execute, our insert into stocks, and I'm going to insert these values. In this case, I'm going to put this date right here, by Google 173.12. Numbers on this exactly don't matter, but the point is I can put this information into here based off of how I structured my table, right? So I can run this now, I'll have my data in there, and then remember that we have to do our commit changes. So the way SQLite basically works is that you have to commit your changes before you actually push them into your database officially. So this is actually a really important step right here. And then once I'm done, I can go ahead and close it. I could have done this separately. I could have commit this, do other stuff, and then do a commit later. But I'm just going to close it just to kind of show you guys, how to do this part. So hopefully that's all review. Any questions you guys have about this stuff? No, it's not good. One thing I did want to note again, just remember this cursor part. I had to make the connection first. So the way I think I talked about this way back, probably a month ago now, is your connection is kind of like your highway, where it's like the way you communicate back and forth with the server, and your cursor is kind of like your cart, or like you can imagine like a person going back and forth. Basically, it's the thing that tells you, it's allowing you to communicate back and forth with the server, and the connection is the pathway of how to do that. So that's why we have this dot cursor. And then after we have that cursor, we can actually do execution. We can do all those different things, okay? So quick thing on here is that I believe, let's see here. So these are some different commands. And so this is more like, this is directly from the curriculum for Module 2, right? But basically they're just different, let's pull this up like this. Nope, okay. Yeah, so basically it goes through some different commands, like select star, hopefully from this is more review because we might have not done SQL in a while. Remember, you can do where. Remember, SQL does not care about white space, so you can put them on new lines, you can put them spaced out however you want, whatever logically makes sense. I tend to write it as new lines, but you don't necessarily have to. And then just know there's a bunch of stuff, like I said, insert, order by, basically orders your stuff, limit, between, this is for like your where clause, null, count would be great for aggregation, like when you do a group by. You can group by. So stuff you should kind of review through. I'm not going to go through it one by one unless you guys really want me to. But something, make sure you read through the curriculum and all the different stuff you can do. Okay, cool. Any questions about commands? Okay, well, that feels pretty straightforward. So our next part then is about table relationships. So a big part of here basically is like when we have our different tables, how they can be connected together. And so this is really important as we do joins. So when we do like a join, like left join, inner join, I mean, technically there's right join and outer joins, but those are much fewer. But usually it's a left join or an inner join. But this allows us to understand how to connect those tables together, right? So the simplest one is a one-to-one relationship. So in this case, this stuff information is taken directly from this curriculum, right? So just know that you don't have to, like you can look this up again. But just a one-to-one relationship, basically it's that there's a connection with a foreign key to a primary key. So for example, here for the curriculum says employee and compensation. Each employee will have exactly one row in the compensation table. You won't have an employee with multiple compensations, at least not the way that database would be structured. So this would be a one-to-one. Basically, for every compensation on there, it would be directly tied to an employee, and one employee will have one compensation. So one-to-one, pretty straightforward. Okay, one-to-many relationship. Hopefully these are all pretty self-explanatory. You can have a city, but has many different zip codes. So you can have a city like a table that encompasses about the city, and then you might have like a zip code table, and that might have information about zip codes. And you can have one city basically connect to multiple zip codes, right? So hopefully that's pretty straightforward in that way too. Okay, and then a many-to-many relationships. This is where you can, obviously many relationships back and forth. So one thing, for example, it's like, let's say you are a customer and you buy items. So like, for example, one customer can buy multiple items. So like in the customer table, they might say things bought, and they can buy different items, right, in the items table. But then also those different items can be bought by different customers. So that's a many-to-many relationship in that sense that basically can go both ways, right? So again, hopefully that's pretty self-explanatory. There's also like 0 to like 1, but those are boring because it's not important if it's 0. But just know many-to-many, one-to-many, and one-to-one, right? And so this right here is our entity relationship diagram, so our ERD. You'll never hear people say entity relationship diagram. You'll say ERD. Usually people will call this like their schema. They'll kind of reference it in that way. And here basically you just see each table. Depending on how it's structured, you might see different things. So for example, this one shows all the relationships of like where each part will be referenced to. So for example, I have customer demographics, I have customer type ID, customer tenant, and I can see customer ID and customer type ID. That's how these two are connected. It's basically through that primary and foreign key. So this would be its primary key in this case, and this is its foreign key here. So this way you can connect these two together. And the reason why we, I don't know if we talked about this last time, but when we have a primary key and a foreign key, the reason why we use those parts in there, you technically, depending on the database, you technically might not need a primary key, but it helps the database structure its information better. And so it makes it much more efficient for it to go through. And that's one of the reasons why we talk about primary keys and foreign keys, even if a database, a SQL database doesn't necessarily have to use that terminology. Again, it's all dependent on what you're using, but most will use primary and foreign keys, okay? This one's always an interesting one. You can see here is that you have a relationship with itself. So you might be able to reference the same things in the same table. So just kind of know that. This also has information about what kind of type it is. Not every relationship data, ERD will actually have all that information in there. It might be slightly different depending on the structure. So this is closer to, and these are both, I believe these are both from the curriculum too, so you can reference those. But this is closer to what I tend to see when it's generated. You'll see basically like you can have some extra information here. It's the same, it's very similar stuff, except there's one extra part. There's relationship icons for one-to-many and many-to-one and all that stuff, relationships. So here we have like our users, our favorites, our books, and our authors. So you can see here, for example, there's one user, right? Each user is unique in that sense, but a user can have different favorites. So like maybe they have multiple favorites in that sense, okay? And then those, for example, an author, right? There's only this one author with this ID, but an author can write multiple books. And so that's why we have this one-to-many relationship right here, okay? Any questions about any of the stuff I kind of went through? And hopefully that's all feels pretty review. Cool. All right. So yeah, so just remember SQLite 3. So this brings us to SQLalchemy. So SQLalchemy is just another package. This one's we're going to use object relational mappers, ORMs. Basically, that object part in there is saying like, hey, you can use an object, right? It's going to be object-oriented programming, and you'll see kind of like what this looks like in a second. I did want to point out a couple of cheat sheets that are in here in this reference. We have these Python cheat sheets, and this person, I don't know who they are exactly, but they put together a really great cheat sheet of just different SQLalchemy parts. So you can see, like, for example, setting up a database. They have things like, let's see here, insert, no, let's see here, getting the metadata, so this is about the table itself, creating a table with same columns, dropping a table. So they basically have these little quick, like, what's it called, references of how to write this. And it's also in a GitHub repo, so you can clone this yourself. Actually, this repo is literally what this website is. So super useful to kind of reference through, especially if you kind of want to see some examples of how to do things. Maybe if you're like stuck on part, it could be a good reference, but I found this pretty cool for SQLalchemy specifically. Okay, but I wanted to point that out. So that's in this cheat sheet reference, which is on the GitHub repo that I push all this stuff up to. But the main thing is we have a package right here, and I am going to go ahead and connect and create. So this we have our SQLalchemy, okay? And I import SQLalchemy, and then with SQLalchemy, I can create an engine. So in SQLalchemy, it's kind of like you create this engine part, kind of in the sense, not a connection. This has got a little abstract in my head, but basically you create something to, like, you can almost imagine your car. Like you create an engine that will connect to something. And SQLalchemy requires you to have this pathway for a SQLite database. So in this case, if you remember, I don't have a musicians.db, but this will actually create an engine object and it will bind it to the database itself. So if I run this, I believe this will actually create, it will first look for, is there a musicians.db? And if it doesn't, I believe it creates one. Maybe not. No, I think you do have to write something to it. But it'll try, if there was one that existed, it would actually try to connect to that, okay? So just know this, we have to start up, we have to create our engine first, okay? Next thing is like we have to actually create this declarative base, and this allows us to use object-oriented programming to communicate with SQL, all right? So you'll see that there's the declarative base, and I'll save it as base. This is pretty common practice, and basically allows us to inherit a bunch of the functionality from this object. So basically, this guy right here, this base, is going to be the base object, and it allows us to do a whole bunch of object-oriented by inheriting that stuff, and we'll see what that looks like in a second. I repeated this again. I think I was showing that you can import star, but I'm not going to do that. Oh wait, no, I do have to do. No, I'm good. I don't need that thing. It was just repeating the same stuff. But you can see I got this part. So now I have this base. So now that's an actual object. In fact, I believe if I go ahead and just run base, you can see that this is a SQLalchemy. Okay. You can see there's the API. All right. So the first thing steps like, well, okay, cool. We got this stuff, but let's do something with it, right? So one thing we can do is actually use very Pythonic, like structure. So this allows us to like kind of make things, instead of using SQL like in a classic sense, we can kind of create things that are much more program based, which makes it a little easier to write if you're not familiar with SQL. and can be super useful in that sense, especially if you get something that's very complicated. All you have to do basically is create this object and use that to create your new parts of the database. So in this case, I'm going to create a musicians table, right? And you can see here I have this class.
Are we switching to always using this, or is this what we're going to be using just part of the time?
I would say SQLalchemy is pretty common. It's
Okay.
not the only way, but it's getting more and more popular, especially. And mostly it's because you can directly program like this. So a lot of like, if you aren't a data scientist, but if there's other software developers, they likely would use something that's similar to what they're used to, which in this
Okay.
case, it just makes it a lot common. So this is pretty, you'll see this pretty frequently. And this is why
It's
like,
kind of just something else to learn, basically.
yeah, it's another thing to learn. It's kind of like another tool. It's
Okay.
like it's like when you learn how to like for example, let's say you get a wrench, but like there's not only one type of wrench. There's different types of wrenches for the right kind of tool, like for the right kind of job. SQLalchemy is one of those wrenches. It's like another thing you can use to do that, and it's pretty common how it's done. It also allows you, kind of looking ahead, it allows you to create APIs. So for example, let's say you're a data scientist, you will talk about scrubbing data and collecting data and putting into a database and everything like that. It allows you also to create APIs, which basically are allowing, which we'll again talk about soon too. It allows you basically to have other people query your information without having to worry about SQL directly. So it just makes it that much easier to kind of more robust to be able to deploy out and stuff like that, which sometimes you as a data scientist have to do. In bigger teams, you might have a software engineer who is data focused, who might do this stuff. But also you could be doing it as a data scientist. Data scientist roles can be very fluid in that sense of like what things you have to do exactly. So that's another tool to know how to do well. Cool. All right. Good question though, Eric. All right. So we have our class here, and then you can see we inherited our base, right? And this is a very specific thing for SQLalchemy itself, is the table name. And notice that double underscores. When you see that double underscore, just know that's kind of like a private, well, underscore is a private variable, not really private, but it's basically private. But the double underscore basically says, oh, this is something built into the system. Okay, so in this case, this table name is kind of like, it mimics that, if you remember that the underscore init underscore, it's kind of that similar thing right here. And this allows us to say, okay, we're going to set the name of the table to this. And then we can actually declare our columns and set their data types. So for example, I can see, what's it called? My, sorry, I'm blanking out for a second. I'm creating my different object variables in here, okay, my properties. And you can see here, I'm using a very specific, this is actually coming from this base part from SQLalchemy, but it's in column and then capital integer. And convention kind of says is that when we do a, when we use a class, we define a class, we use capital letters. So you can see like base, musician here, column, integer. That way we know immediately, oh, that's supposed to be a class right there, right? So basically this says, all right, this ID is going to be an integer and it's going to be the primary key. And then we say, oh, there's going to be another column in here called the full name. And there'll be another column and it's going to be a string. There'll be another column that's instrument, which is going to be an integer. And you can see there's also a foreign key here. So you can start seeing the structure without having to actually like make the SQL parts of it. You basically can do it more with the object-oriented programming aspect of it, which again, object-oriented programming is really great because we can make it more robust in general. So I create this musician here. Okay, oops. Oh, because I did not import this guy. I'm importing everything, which is not the best, but we're just going to do it so it's easy to go. So the reason why it gave me an error is that it doesn't know what column is because I didn't explicitly import column. So I'm just importing star, which you'll see a lot. Just be kind of careful with this, to be perfectly honest, just because this imports everything. And if you're not sure what everything's in that package, in that library, you might accidentally import something and then overwrite it, or this import might overwrite the thing that you wrote. So just be careful with that. But anyway, what? Okay, maybe I'm wrong. Invalid request, musicians already, I already defined it. So apparently that's probably because I have this. Well, that's weird. Let's try, sorry guys. I might have run something wrong, so I'm just gonna do a restart real quick. I'm gonna run this guy, run that, do import star, and now I should be able to run that. Okay, good. I think I ran it twice, which is probably why it gave an error in that sense. So I just did a restart. And then I'm gonna do the same thing with my instrument here. You see that idea. It's a new table, which in this case, every table is a class, which makes it nice and easy. All right. So I have my class, or sorry, my instrument and my musician. And now I can actually take my engine, right? Which should already be started up, but I'll go ahead and trust pass Victor to make sure. I'll trust pass Victor and make sure that's what they wanted. And so good. So I have my engine. I just redeclared it in this case. It doesn't really matter. But then I create my engine here. So it starts up our engine and basically uses what's it called? Creates those tables. So you can see here, it uses a create table. And this is SQL right here. But all I had to do was use the classes that were defined previously up here. So it makes it nice and easy for us to deal with. And so we run this guy right here. We run it here. I basically are creating this table. So now if I go back to my files, you can see my musicians DB exists. So you can see that we created our new tables in here. And that's what our engine basically is doing. When we create all, it's creating everything that was tied to base, which includes my musicians and my instruments class, which are essentially tables. Okay. So any questions a little bit of what's going on here? If I were to break it down, like to summarize, basically SQLAlchemy allows me to create a table by just defining a class. And within each of those tables, which are defined with classes, I just have property names. And that will create, you can see here, ID, full name, instrument. That creates my columns within the database, in my SQLite database. Okay, so cool. All right, so I'll move on then. So CRUD, you'll see this a lot. It's basically create, read, update, and delete. And so basically the idea here is like, you know, the things that you can do. And it turns out with SQLAlchemy, you can do all of these parts. So I can create stuff, I can read things, I can update things, and I can delete things. So you can see, for example, I have my neighbor. I'm going to instantiate an object called my neighbor. He's a musician. I'm giving my neighbor its full name is Bob Rose. And I'm saying my neighbor is alive. Okay. And at least for now. And then I have an instrument called drums. I make sure it's called, you know, its actual name is drum, so I can reference that within the table. And I'm basically giving an instrument type. I just called it loud. And this is based off of, if I just show you a little bit, my instrument right here, you can see ID, name, instrument type. Note that I didn't have to give it ID here. And the reason why is because it'll figure it out for me. I don't have to explicitly define what the ID is. Basically, it'll integrate, or it'll, what's it called? It'll increase as I put more and more items within my database. And you can see I have my stuff right here for musician. And note that I didn't put it in for my neighbor. I didn't put down their date of birth or alive, so those will be null. Okay. So I run this now, and I make sure my neighbor has the drums.id, so that way I can reference my instrument for my neighbor. Okay. So I run that. So that was basically creating new things. And now, now that I created things, I can actually update it, right? So in order to update it, I have to create something called a session. And this session basically allows me to like say, all right, I'm going to do stuff while I'm in, I'm going to do stuff to my database. So I'm importing this session maker, okay? And this allows me to bind that engine. So I take that engine and I say, all right, I'm going to use a session on here so I can do stuff to it. So I run this guy. And now I can add all of my information, all of my new objects, which will be data, like rows in the data table, okay, into my session. Okay, and you can see here, it's just simply a list of my different items. And I do that and I can commit it, and cool. You can see here, I do an insert right here. All right, so hopefully that feels pretty good. And you can see now too, if I do drums.id, you can actually see that I can actually get what the ID is right here. And note that I didn't define ID previously, but it allows me to do this part. I did have an echo equals true. If I didn't have echo equals true, you wouldn't see any of this. This is just showing you like what's happening in the back end. So you can see here a little bit, if you read it, it's basically doing, what's it called? SQL. So you can see it says select instruments as instrument ID, and all these things from instruments where instrument ID equals, and it's a question mark. Basically, it fills in the fact that it's going to be from this specific drums.id. But if I do drums.name, it should also give me the name. You can see drums. Okay. And then I can do the same thing. What do I have? Musician? Or no, my neighbor. So my neighbor, if I just run this, you can see it's just an object, so I can't tell what that is. If I do my neighbor dot full name, I believe was one of the attributes. Bob Rose. Okay. So you can kind of see that. And let's just check if it's alive. Was it alive? Yeah. He's alive for now. Okay. So anyway, that's how you kind of are able to create those things. You can also delete things and everything like that. So kind of get the idea. The main thing to realize here is you have to create a session, and that session is tied, it's bound to the engine for SQLalchemy. And I don't have a good analogy, to be perfectly honest, about like a session versus an engine. But basically you can kind of think of it as like, my engine is the actual database itself, and my session allows me to interact with that database, okay? And that's why we have to bind it right here. We have to bind that session, or we have to bind the engine to that session with the session maker function, okay? So cool. So after we create our database, we can actually access it. So we can imagine like this already exists. In this case, I have my musicians database, right, that already exists. I create my engine, so I know how to connect to it, right? And in this case, I'm just using some f-string just to kind of show you what you can kind of do, make it a little easier. I took out the echo equals true, that way I don't have to keep seeing that extra background information. I create my new session now, and then I can actually do something like, for example, get information. So this is all SQL stuff, and the curriculum goes into more detail specifically about going through, but I'm kind of showing you the things you can do and interact with it. So for example, from SQL import inspect, I can do inspect equals inspect engine, right? And then I can actually print out that information about the tables. So if you first connect to a database and you've never seen what's in it yet, you can now use this function right here to get information about like, hey, what's in this database? So for example, you can see this new table, or these two tables in here, okay? So it's like, oh cool, I have a table called instruments and musicians, and it's like, okay, I'm gonna just put my table name equals instruments, my columns, let's get all the columns of that table name. So I do this now, and you can see here as I get all the information about each column. So in this case, you can actually see if I, let's see if I do this right. If I do type, for example, of my columns, you can see it's just a list, right? And so if I say, let's say type the first thing in that list, you can see it's a dictionary. And that kind of makes sense if you look at what this looks like. It's a list of dictionaries. And each dictionary, right? So the list is all the columns. Each dictionary is that column. And in that column is information. For example, what's its name? What's its type? Is it nullable? Like, for example, can you make it null? And some of them are, because that was by default. Primary keys can't be nullable. That's why automatically it says false, even though I didn't define it myself. If you have defaults, for example, certain databases, you can actually have it a default automatic come in. And then auto increment, basically, like I kind of said, like if you have an auto increment, if you input something that's not there, it'll automatically increase it by 1, okay? So that's, again, how you can get some information without ever having to know about the database, which hopefully you can kind of see that's pretty useful. You don't have, like, I don't know about you guys, but SQL is fine, but it's nice to know that you can use pure programming or pure like Python without having to do any SQL back and forth. Okay. So you can, however, use SQL if you really want to, right? So here you can do execute an actual query. Okay. And then you can see, for example, select star from instruments. You can do this guy. And you can see, oh, there's in this case, there's only one column in here. So it's just like, okay, here's one, drums. And then this column right here, which none is instrument type. Okay, so I don't know if I didn't put that in there, but that's what this comes out from here. And then you can do it more. For example, you can basically combine it with pandas. So once you have this query, you can see right here, it's just essentially a list of tuples, which pandas is perfectly fine with, and you can actually import it directly in here. Just note that, I think I showed this before, way back in section 5, is that you have to define your own columns. So you might, for example, have to go through columns. If I wanted just the name of the columns, I might do something like let's just do, I'll call this A for now. So columns for, oops, I'll call it C dot, so this is a column dot name for call in columns. So this will iterate through the list of dictionaries. So each call, C-O-L, is a dictionary. And in that dictionary, I want just the name. I could have also done, if you're more comfortable with this way, I'll do the same thing for a dictionary. Okay, and this will create basically the list of my columns. So for example, if I put A now, you'll see those are all my columns here in the right order. Okay, ID, name, instrument type. So if I wanted to, I could do something like this with calls, columns equals, I define it as A up here. So I just put A, and this should have now, oops, no, I didn't like that. Oh, duh, because I have to put this as data. Sorry, guys. Oh, no, assertion. Oh, I have musicians, that's why. So I have to actually use it from the right data table, or table. Is it musicians? Yeah. So now I have this part, now I have all the musicians, and now I have the data, my columns, and you can see now it's out fine. So this is how you can quickly, like, very generally make tie Python in SQL, in a SQL database together, right?
Could I ask you something?
Yeah, go ahead.
Well, there is an option to use SQL language, and there's an option to use pandas. Will, since I'm used to using SQL, if I use SQL, will it slow down the execution time?
So I guess it depends on the situation. What are you thinking? Are you thinking of something in particular?
In terms of just very large data sets.
Yeah. So you're talking about like querying the database. Like, are you talking about like how I did this right here? Or are you talking about when we, because we could talk about, sorry, go ahead.
Just in terms of querying using.
Yeah. So I'm trying to think, I want to phrase this. So it depends, basically, what it comes down to. So in some situations, for example, if you just need, okay, let's say you're talking to a database, right? That's far away. So there's some bandwidth in the network, and you're talking to that database, and you need everyone who is at least 42 in as a musician, just kind of randomly stuff going through here. And so it turns out the amount of the full database is, let's just make somewhere like 100 million names in there. But you expect that the number of musicians who are at least 42, there's only about like 1,000 people in that database that would fit that thing. It makes sense for you to say, hey, like basically send your SQL command to the server. That's what's going on here essentially. You send your SQL query off to the server and say, hey, get me everyone who is 42 and is a musician. Okay, and then it'll basically crunch that over where the server is, and then it'll get that information and bring it over to you, and now you have that information. Okay. However, if you had something where it's like you have, let's say, you have like a very, like it's only a small number of people on there or something like that, but you have a lot of like very complicated like query and stuff like that. And you like have the server calculate, do like all of that computation and then bring it over. But you know that if you just queried everything, say, give me everything that's, you know, like, I don't know, just give me everyone. And that's, everyone is relatively small and it can be passed on the network very quickly. And your side is a much better computation. It's possible, not necessarily for certain, that your use of pandas will be faster than using SQL. And basically I can say is it depends. And also it depends how well you write your SQL query. Sometimes, for example, when I was working at a credit union, I wrote a SQL query, like one query, 400 lines. And it was massive. And it was, to be perfectly honest, it was hard for, like I wrote it, but it was hard for me to like, parse through and like debug it and things like that. There just aren't that similar things in SQL. And what I ended up doing in the long run was I imported the information. I did part of the query in SQL, imported it into pandas, and basically do it from pandas from there. But that's only because I had enough information. I could hold all the stuff in memory, versus my SQL query. My SQL query, when I'm doing this, would take, and this might be more on me that I'm not amazing at SQL. So like I could have there's probably ways I could have optimized it. There's whole like thick books of like SQL and talking about how to optimize SQL and everything like that. And if that's something you're interested in, definitely, look into that. But when I would run this thing, it would take like 10 minutes to run through and then give me the information of about like less than 10,000 items. And it's like, well, I could get 10,000 items and sort through pandas a lot quicker than I could running the SQL query. So I was like, well, you know what? I'm just going to grab it in there and sorted it through with pandas a lot easier. So basically, kind of depends. That kind of, if I was, to be honest, if I was better, like if I had better knowledge in data engineering, which I'm actually learning some of this stuff right now. Looking into like data engineering and seeing like other things are there. I might be able to tell you a better, like, oh yeah, in this situation, it'd be this way. But to be honest, all I can say is like, it depends.
Okay.
Yeah.
Thanks.
No problem. And just know that too, is that this is only talking about SQL servers. So there's also things called NoSQL and NoSQL, which means it used to be not SQL, but now it's not only SQL. Weird, I don't know. But NoSQL basically is like, okay, you're not using a SQL database. It's not real. There's other ways you can form around this. One example of this is like Hadoop. There's things with AWS that you can create. And that's a different kind of structure. For example, it's Apache Cassandra is a NoSQL database thing. And you can technically try to use SQL, but if you use traditional SQL methods, the way the database is structured, it's hierarchy. It has a hierarchical level, and you can't just simply mismatch things. You have to call it in a certain order. And essentially, there's optimizations of reasons why you do this kind of thing. So this is very much more data engineering, which we like, that's kind of a separate side of like data scientists. If you think of like what a data engineering is, it's kind of like creating like, well, I'm not talking down in this way, but it's kind of like creating the pipes and like the plumbing of like getting that data. But it's a very, what's it called? It's a very, I'm trying to think of the word for it. It's a lot of work, but it's an important work, kind of deal. Is if you don't structure your database correctly or well, then getting the data from it is going to be a huge pain and trying to sort things out. So that's where a data engineer comes in. So yeah, this is where we start snowflaking and kind of branching out into different parts of like what areas to focus. Okay.
Okay.
All right, cool. Yeah, and I guess kind of on that a little bit, I didn't mention it before, but it talks about in the curriculum, is that I think it's like in the curriculum right before the one-to-many, many-to-one relationships kind of deal. There's also called something like normalization of tables. And that's different from normalizing a database, normalizing like your data back in Mod 1 project. Basically, it's something like called like tidy data. Basically, it's like, how do you structure your database to optimize how to query off of it? And there's different like norm factor 1 and norm factor 2, or NF1, NF2, and stuff like that. So just know that these are like, again, this is more data engineering part. That's not what we're gonna worry about. In this scenario, it's like, oh, it's already designed in some form or fashion, so you don't have to worry about those kind of structures. Okay, cool. Well, I believe that's all I had planned for you guys. So any other questions that you want to ask? Anything you want me to walk through on this part? Anything at all?
How did you get the executed in 6 milliseconds finished on this day?
Oh, this guy right here?
Yeah.
Oh, okay. Yeah, that's a Jupyter Notebook extension. I can maybe show you guys this. So this is actually fun too. Is this right here? You'll notice I can fold and stuff. That's another extension you can install. I actually wonder if this here. I think I can show, since I already have you guys here. You can see all these different extensions that you can install that are NB extensions, and you basically can use this stuff to do certain things. I believe you can just go, I'm trying to remember. I'll have to show you guys maybe some other time because I can't remember off the top of my head. Because once I install, I don't really think about it. But you can install extensions onto Jupyter Notebook. So one I actually have, which is super useful for me, is if I type in like something in Markdown and I misspell something, it'll highlight it in red. So let's say last like this. But if I put like last, so that's useful too. It won't immediately correct or anything like that, but it's a basic spelling error and stuff like that. So I can point to you guys some of the extensions and stuff later on.
Okay.
Yeah, that's built in. So this is actually a fun way you can do like timing stuff. You can also do things like, if you don't have this built in, or like you didn't install the extension, you can also do time. So oops, this is not code. This is, there we go. So we can do this time. For example, I can do like print 1. Oops, yeah, and you can see it'll time me, and you can see that's how long it's giving it right here too. So for example, if I do something like, let's say do like for I in range of, I have to actually do something. Just say I. Okay, so I'm not doing anything other than iterating through. You say, oh, 364 milliseconds. But if I put in, I don't know, a few extra zeros, yeah, it might take a little bit longer, right? And eventually it'll tell me how much time to go through. Maybe that was a little too big. Got too excited. But you can see it's like, okay, this is a little bit longer. If I put like 1 extra zero in here, you can see that time increases. So this is a good way to time out. It's like, oh, how long it takes things, which could be useful, for example, if you're trying to compare SQL versus pandas. That can be useful in the sense of trying to figure out how long each part will go. Okay.
That would have been cool with the whole train test split stuff when it took a little bit of time.
Yeah, it's always fun to see like, oh, how long did it actually take?
Yeah, exactly.
And yeah, we're going to see this a lot in like machine learning too, where it might literally take hours for the learning to go through, and hours is like, oh, that's relatively short. The really intense stuff can run literally for days and weeks, of course, and those are on higher end computers. That's not on a laptop at all. So yeah, but right now we're not going to do some of that. That's going to be more close to the mod 4 where we do more deep learning and stuff like that. So deep learning, a lot of image processing, like to do full convolution. I won't get into it, but if you do something like convolutional neural nets and you basically do very big data sets, it can take a long time for it to train. There's some already pre-made machine learning architectures, excuse me, like ResNet 50, which took I think it took a few weeks to fully train. But now once you train it once, you can do transfer learning, which makes it, you can do it within like minutes or, at worst hours. So yeah, cool. Anyway, that's not this stuff, but something to look forward to. Cool. Yeah. So any other questions you guys have? Anything you guys are curious about?
That's it for me.
Okay, cool. All right. Oh, I guess I could stop recording now.